Hi everyone, this is Mrs. Crew and I'm going to be reviewing the scientific notation portion of your test. This is question number 1. A virus is very small compared to a human blood cell. A virus is about 0.0000009 meters. What is that in scientific notation? So you have to think about this number is very, very tiny. So if this number is going to be less than 1, then your exponent is going to be negative. So when you look at the options, option A doesn't even have a negative exponent, so that clearly is not the correct answer. Answer choice B doesn't have a negative exponent, so that's not the right answer either. So what you're going to do is I would rewrite this number, and you have to count how far is it from this spot where you have your decimal to behind this first number. So you're just going to count over 1, 2, 3, 4, 5, 6, 7. So the exponent would be -7. The first number would be 9. And scientific notation is always times a power of 10. So the correct answer is C. The biggest mistake people make is they're like, oh, I'm just going to count the number of zeros. You do not count the number of zeros. That does not give you the wrong answer. That's where this incorrect answer came from, because a lot of people make that mistake, so they make sure to put that as one of the answer choices. Question number 2. It is about 93 million miles from the Earth to the Sun. What is that in scientific notation? So when you look at this, you know that this number is much larger than 1, so this is going to have a positive exponent. So since this is going to have a positive exponent, you can go ahead and narrow down your answer choices. So no one should have chose answer choice C because that says -7, and no one should have chose D because that says -6. So the first thing you should do is write down your number, and if your number does not have a decimal, then the decimal is always placed right here so that you do not change the value. We have to count how far will it be from this spot to this spot, because in scientific notation, our first number has to be between 1 and 10, so we always put our decimal there, so this would be 9.3 times 10 to the something. So our power is how far did we have to move this decimal to get it here. So we're just going to count 1, 2, 3, 4, 5, 6, 7. So it should have been a positive 7. Another way to look at it is you can count how many numbers are there between those two decimals. 1, 2, 3, 4, 5, 6, 7, and you get the same answer. So the answer to this question should have been A, 9.3 times 10 to the positive 7. Question number 3. The distance from Earth to the Moon is 2.3 times 10 to the 5th. What is that in standard form? So standard form is when you take scientific notation and write it as a regular number. So when this exponent is a positive number, you know that you're going to be moving your decimal to the right. The way to remember that is all the positive numbers are to the right of 0, and all the negative numbers are to the left. So when your exponent is positive, you're going to be going to the right, and this little number tells you how many spaces to move it. So in this case, we're going to move it 5 spaces to the right. So we have the number 2.38, and we're going to physically move this decimal 5 spaces to the right. 1, 2, 3, 4, 5. Every space you see a little dip, you're going to fill in with the 0. And now we're going to rewrite the number because this decimal is no longer here. We have moved it to this spot. And this is our answer. So when you go back and look, you need to be careful and make sure that you pick the correct answer. So A is incorrect. If you add your comma, it helps out a little bit. This is way too small. This says 2.38000. This should not be confused with a comma because that's not where a comma would be placed. So this is incorrect. The correct answer choice is D. Question number 4. drag and drop the boxes in order from least to greatest. So we want to go smallest to largest. So when everything is in scientific notation, this is very simple. All you're going to look at are the exponents. So we have a -2, a -8, a -2, and a 3. So it may help if you draw a number line and place these numbers on the number line. So I have a +3, I have 2 -2s, and I have a -8. So when you think about small numbers, the smallest numbers are always going to be towards the left-hand side. Numbers get larger as you're going to the right. So the number that is farthest to the left is -8. So that's going to be our smallest number. So what should be dragged and dropped into this box would be 9.2 times 10 to the -8. The next smallest number we get to is going to be -2. And here we have two numbers with the same exponent. So when it comes to that, what you're going to look at is a number out front. So once again, we're trying to find the smaller of the two. So we list them lined up with their decimals. So I have 5.44 and 5.8. A lot of times we like to make sure they have the same number of digits, so we would just add a 0 here. And if you think of it as money, it makes it a little bit easier. So this person has $5.44 and this person has $5.80. Which person has the lesser amount of money? 5.44. So this number would be the next smallest number. 5.44 times 10 to the -2. So then we have the 5.8 times 10 to the -2. And the largest number is the one with the positive exponent. 2.4 times 10 to the third. Question number 9. The table below shows the distance from the sun of 4 planets in our solar system. Mercury is the closest planet to the sun. Which distance below must be Mercury's distance because it is the least value? So once again, if you look at all these numbers, they're all written in scientific notation. So what we're going to examine is we're going to examine the exponents. So we have a 9, an 8, a 7, and an 8. And we're just figuring out which one of those numbers is the smallest. So the smallest number is 7, and that corresponds with planet C. So the correct answer is planet C.